Hey guys, it's Anna. So, I have a lot to do. I have a lot to say in this 10-minute time period. So I'm just gonna get right into it, and I hope you enjoy. I'm going to be talking first about my research question, and as well as some of the sub questions that I had to look into to, answer this question. So my research question is: how does the affiliation between dark matter, light and optics, and the gravitational force of the galaxy interact with each other to keep the density of our galaxy from collapsing in on itself? So essentially, what it's saying, I know it's a lot of words, but it's saying, uh, you know, what does dark matter, light, and gravity have to do with keeping our galaxy from essentially destroying itself? I know, right? Pleasant thoughts. So some of the sub questions that I had to look up were: what is dark matter, and how is it different from the visible matter that we know? Um, what is gravity, and how does that play a role in keeping our galaxy intact with orbitations and all that kind of stuff? How Another question is: how can the light spectrum help us grasp the concept of dark matter, and help us understand it better? And how can we use it to understand to hypothesize different theories of it? Um, and what is the purpose of dark matter in our galaxy? Like, what is its nature? What is its purpose? And how does understanding dark matter and its composition benefit? So I want to start off with talking about what is dark matter. And so, as you know, there are many astronomers that believe that the universe was created during the Big Bang. During the Big Bang, when a burst of energy had essentially created all the clusters of stars, planets, and celestial bodies that we know. And as you know, these planets, stars, and celestial bodies are spinning and rotating around our galaxy, and they're actually spinning at really high speeds, and they're actually spinning at such high speeds that it should be impossible that the matter that we see and know about can actually hold it all together. I'm going to talk about later, but the visible light or the visible matter that we see actually only makes up 4% of the composition of our entire universe. So there's absolutely no way that the visible matter that we see can hold all this together. And as you know, as per popular belief, um, the planets and celestial bodies are closer to the sun, spin faster, and the ones that are farther away from the sun, they spin slower. That's what we've all been taught. But actually, these planets and stars and celestial bodies on the outer edge of the galaxy that are farther away from the sun are actually accelerating and are going faster than those close to the sun. And it should be impossible for them to stay in orbitation of our gravitational pull of our galaxy. And that's when astronomers started to question, well, there must be something we're missing. There must be something that's keeping us together, like a kind of glue that's holding our universe together. And that's when we get the notion of dark matter. So dark matter is essentially a type of gas that's so hot that no visible light telescopes can see through it. And these dark matter these and this dark matter does not actually interact with the electromagnetic field like the visible matter that we know, which means that it cannot absorb, reflect, refract, or emit any source of light whatsoever. And this is actually why we cannot see it, because it's beyond anything in our visible light spectrum from the 400 to 700 that we can see. The gas can actually only be detected by X-rays and gamma rays, and has been discovered to be in abundance between clusters of stars and planets in our galaxy. And here there's an image of dark matter that we've gotten through gravitational lensing, which I'm going to go talk about later. And here you have something. It shows you the difference between dark matter that was founded 8 billion years ago in a far-off galaxy, and then here one that's founded closer to today. And it's really interesting how there's just different places that you can find dark matter. So essentially, I'm going to go through this really quickly. Dark matter was actually a Swiss astronomer named Fritz Zwicky who first associated the term dark matter with the invisible substance. He actually studied the velocity of stars and planets in our galaxy and did this by examining. So he took the weight of the planet and as well as its position among the cluster of stars, and that's how we determine these things. And he was actually the one who noticed that there was much more mass involved in the orbital velocity of these planets, than the visible light matter that we can see, according to his calculations. And that's that extra mass is actually allowing us to stay intact with one another. Stay intact as one galaxy, and something that we cannot see because light cannot travel through it. And it wasn't until Vera Rubin and her team came along when they really set that notion into stone that there is something else out there. When they had discovered that single galaxies had more mass than just the mass visible to the human eye. So there are two forms of dark matter. There is baryonic matter, which is essentially the matter that we know. So it's the basic composition of an atom with the protons, neutrons, and electrons, stuff that we all know, as well as, essentially what makes up everything we know, from the elements on the periodic table to the numerous stars and galaxies in our universe. Versus the non-baryonic matter, which is the theory that dark matter can also be beyond the known standard model, and has been a theory that physicists have had for years but have not found a way to test. And it's actually how we know that dark matter is doesn't follow the theory of relativity, and it's cold, and that's how we know that we're not. So gravity. So here we're going to talk about gravitational lensing and how we learn more about dark matter. So gravity, as we all know, is the force that attracts the body towards the center of the Earth when we're talking about being on Earth, or towards any other physical body having a mass. So it's essentially gravity that is keeping our solar system from colliding into other solar systems or from collapsing in on itself. It's keeping us in rotation, it's keeping collisions safe, and all that fun stuff. You have refraction, which is the bending of light as it travels through one medium to another. And then you have lenses, which is a transparent object that refracts light rays so that they converge or diverge. In this case, they're going to all converge into one place. And so essentially what gravitational lensing is that gravity is what bends light from objects that are far off in space and turns them into observable images that the human eye can discern. And it's actually how we study dark. This is the method that we use to study dark matter. See objects that are way out in distant galaxies away from space, and it can help us obtain a stronger and better knowledge on its nature. And, here we see this distant galaxy. It has light rays that are being refracted when it comes into contact with the dark matter. And then those lights converge, all that light converges into one space, into one image that we can see on Earth. But as you know, refraction makes images that appear in different areas, so the images may appear slightly off from where the actual galaxy is. So there are three main components that make up our universe, and that ensure that there is balance between the matter. There's dark energy, which is 74%, dark matter, which is 22%, and visible matter, which is 4%. So as you know, we don't really know much about this galaxy yet. And although we didn't really talk about dark energy, it's important to know that it's still there and that it's such a big part of the composition of our galaxy. So the galaxy, there is essentially, there has to be a balance of mass to keep us from collapsing in on ourselves. So essentially, the galaxy, our universe, it keeps expanding, it keeps growing, and it's going to keep on going forever and ever. Or so we think. So there's three scenarios that can happen. First is if there is not enough mass, the gravitational pull of the universe will not be strong enough to withstand, and it will stop the expansion, and stop the expansion, and it will continue forever. And that will lead into collapsing in on itself and all that stuff, and we'll end up pretty much dead. So Then if there's too much mass, the universe could end up caving in on itself and contracting, which causes it to collapse in on itself. And then you have, if the universe is balanced within, if the mass is balanced within the universe, the expansion of the galaxy will eventually end millions or even billions of years into the future. And here's like the composition. You have 74% dark energy, 22% dark matter, and the 4% atoms. So it just shows you, like, we don't really know much about our galaxy. It's still all new. So here we are back to our research question, the affiliation between dark matter, light, and gravity, and how it keeps our galaxy from collapsing in on itself. Well, the answer is the dark matter that surrounds us in our galaxy and in other galaxies acts as sort of like a glue, if you will, or stabilizer for our galaxy, and it creates a stable gravitational force that one cannot get from just the visible matter that we know of. As the celestial bodies and planets are accelerating, I'd say, or going the farther they get from the sun, going faster, they need dark matter so they don't end up colliding into other distant galaxies or collapsing in on itself. And light and optics in the whole grand scheme of things, it just help us understand the nature of dark matter, with gravitational lensing and how what its purpose truly is. And then you have here dark matter, which keeps it keeps the fast accelerating bodies, celestial bodies from collapsing in or on itself or colliding into anything else, and keeps them in our gravitational force. Thank you for listening in, and hope you're all staying safe, and hope you have a great Thank you.